All right, good morning, guys. So, yeah, after 1 week, I believe you are already a little bit familiar with C++, right? And as requested by many of you, I will hold an office hour every Thursday afternoon, 2 p.m. to 3 p.m. in my office, E1 512. Uh-huh. Oh, your class time? Yeah, it's very hard to find one slot that's comparable to everyone. I will make some adjustment here. Yeah, I saw some of your class schedule. Someone shared through WeChat, especially on Friday, right? Friday are busy week, are the busiest day, right? Yeah, maybe I should find some day, such as Tuesday as well. Yeah. So for another office hours, we have changed the room from 2 to 8 to 2 to 7 because 2 to 8 is already booked by some other classes, right? And the time doesn't change. I believe the first office hour will be most available, right? At night. All right. Okay. So yeah, that's that. And I have already seen someone asking questions in here, right? The discussions. It's very good. And we have TAs will periodically checking if there's any unanswered questions. So if you have any questions, you post it here. After maybe at most 1 or 2 days, TAs will answer your questions, right? So you don't have to come to TA's office hours. And another good thing about it is it asks you to organize your thought, organize your language, right? How to ask questions online. Yeah, I see most of you just like to paste the screenshot right in here. Yeah, so it's fine. And yeah, let's check what are the problems. When I run my program, the following errors appear. All right, it's basically your include path. Maybe you should reinstall your libraries. Next one, how can I do subtraction on strings? So you are learning very fast. So strings are maybe 3 weeks after today. All right, we will learn the whole class about strings. So at least for now, what you need to learn is, okay, string is just a bunch of characters, right? Actually, string is a class. It's a class, and there are many methods, or we say functions, defined on top of strings, right? You can capture a substring of a string, right? For this case, you want to subtract A. Actually, you want to get the substring from B to E, right? And in the future, if you learn how to do it, it's just S dot substring, and you put the index. For example, B's index is 1, and E's index is the final one. So yeah, so string is a class. We will introduce it later, but at least for now, you just remember strings are just this kind of characters. It's fine. And what else? Why too slow? All right. My program runs with strange numbers appearing. All right. Let's see. I don't understand why the number 12142 appear. All right, that's actually quite common, right? When you put a slash versus backslash, right? If you want to print a new line, it's a backslash n. Actually, in C++, this kind of special characters start with a backslash instead of a normal slash. All right, so if there are more, maybe. Why don't you use goto? Oh, you are faster. You are begin to learn the loops, right? And also jumps. So goto are not suggested to use because if you use a lot of gotos, you can destruct. You can almost other people cannot understand your code, right? In some place you say go to that place, and in the middle of your code you say go to another place, and we will cover that later. All right, ask for some practical extensions, how to use VS Code. All right, so that's basically the questions. And let's jump back to our classes. So last time we have already covered what are variables, right? What are types and what are variables. And when you define a variable, it's actually opening a slot in the memory of your computer, right? So when you declare a new variable, you have to define its type because compiler need to know what's the space, right? They want to put it to you so that you want to store your variables. So that's why we define a type and a variable names. So it's like whenever you define a variable, it gives you a house, right? The house has an address in some place. It has the storage, right? How large the house should be. And the variable is the alias or the name for this house. So you can store something in that house. And how big it is decided by the type, right? If you define an integer, most likely you are defining 4 bytes or 32 bits. If you are defining a double precision floating point numbers, you are basically, it's a 8 byte or 64 bits large size of storage, right? It's a bigger house than an integer. So when after you have defined some variables, you can start using it. So how to use it? You can assign new values to it. You can do operations on it. You can print it and so on. So the most simplest one is the assignment, right? You assign a new value to a variable. So left-hand side is the variable name, and the right-hand side is an expression. So as you can see, we can assign HKUST Guangzhou to a school name, right? School name is some variable we have defined earlier. That type is maybe string, and we can assign a new value to it. And we cannot do the reverse side, right? You cannot do assign school name to HKUST Guangzhou, right? It's not doable. Remember, the left side has to be a variable. If you say HKUST Guangzhou equals school name, it's invalid because HKUST Guangzhou is not a variable name, right? So what it does is, remember you have declared, right? Declared from the beginning, declared this variable. The compiler have allocated a house for you, right? And you put some data into that house. So that's basically assignment. And this equal, we call it an operator. It's actually an operator. You can think of it as a function, right? It's a function that do some work. The work is put the value into your variables. And the expression on the right-hand side, if there are more than that, right? If the right-hand side is 1 + 2, 2 + 3, or a string, a substring of a string, and so on. So the right-hand side will be evaluated first. Then it will be assigned to the variables. We will see an example. What does it mean? And if the right-hand side changes at a later time, the value is not reflected in the left-hand side. So it is executed only once. It's not binded to another thing, all right? Let's see this example. First, we define a new variable called school name, right? We give it some values, assign some values to it. Then we define a new variable, new school name. It is assigning the school name to it. Remember, we are not binding this variable to this variable. This line only executed once. So this new school name will get HKUST parenthesis Guangzhou, right? After that, you assign a new school name to your only one, this school name, HKUST Guangzhou. What's the output of new school name? What's the output of the second variable? Does it include this parenthesis or it doesn't include the parenthesis? Yeah, it doesn't include the parenthesis because this line only executed once. And in the future, we will learn something called a reference. And the reference means this guy changes, this guy also changes. But for now, you just need to remember this is a normal assignment. When this is assigned, it only assigned once, right? And later modifications will never be reflected on this. Right? This is a very simple example. How about this one? Right? This seems more complicated. I equals to j equals to k equals to 0. So if from the math field, right, it's very easy, right? It means everyone equals to 0. So what does it mean by j equals k equals to 0, right? We said we evaluate the right first. We say I equals to something, right? So we evaluate the right-hand side first. Yeah. And when we evaluate this one, we say we evaluate j equals to something, then we evaluate k equals to 0 first. So this one is exactly the same as, let me use something else. Let me hide it. Let me create something. It is exactly the same as I equals to j equals to k equals to 0, right? We said the right-hand side evaluate first. So the right-hand side evaluate first, assign to the left-hand side, then assign it to the left-hand side, right? So these are something, the orders of assignment. And when we say k assigned to 0, we do actually two things. First one, we assign 0 to k. Second one, we return k. Right? So after this operation is done, k equal to 0, and at the same time, we return k. So the new expression becomes j equals to k, right? And then by the same way, we assign k to j, which means j becomes 0. Then this operator returns j, right? It becomes I equals to j. So these are the orders of evaluation, and it also means the evaluation. Wait, let me close it. All right, where is it? Oh, I need to find out where the page is. Oh, it's not this one. It's in here. All right. So that's example 2. How about example 3? Right, we have more assignment. First one, we assign 1.9 to some floating point number, no problem. Then how about we assign the same number to an integer, assign a to b, right? We haven't covered that yet, but this means it's a type conversion, right? It's allowed to do that. They will implicitly convert some floating point number to an integer. So what's the value of b? Is it 1 or 2? 1? Yeah. Most of you are correct. The answer is 1. Right? It will truncate everything behind it. So this is a type conversion. You can try it in your laptop. And also, how about next one? We assign b again to c, and the c's type is double. What's the value of c? 1. Yeah, it's 1. Right? So it's right. It's 1 or 1, 0. It's fine. It's basically they are the same thing. So it's no longer 1.9, right? You're assigning b to a, now assign a to b, then assigning b to c. It doesn't mean so in math, right? When we say a equals to b, c equals to b, it means a equals to c, right? It's not the case because there are some implicit conversions. So now this floating point number doesn't it's not equal to the original one. All right. So next one, integer a equal to integer d equals to character a. What's the value of d? 65. Yes. 65. When you're seeing this, right? When we say characters are and integers are basically the same. If you look at the ASCII table, right? Last time I've shown you the table. The whole table contains the integer numbers and also the characters. So for this one, it's also fine. And also similarly, character E equals to 97. What's E? Yeah, it's lowercase a, right? Yeah. So any questions on this? No? So assignment is very easy actually. let's go to this one. How to swap two variables, right? So the code is like this. Initially, we have integer I equals to 10 and j equals 20. And we want to define some operations so that I becomes 20 and j becomes 10, right? So I have write this. How about j assigned to I and I assigned to j? Both. Yes, you need the three variables. Yes, you are correct. So because C++ is executing line by line, right? When you read this code, you need to read line by line. The first line tells you I equals 10, j equals to 20. So the second line tells you, okay, I want to assign j's value to I, right? Initially it's 20. Now I becomes 20. Yeah. Then how about this one? Now I and j are both 20. So I assign I to j. Still both of them are 20, right? So it doesn't matter whether you write them in one line or two lines. You can put it in one line. I equals to j, semicolon, j equals to I. It doesn't matter. You said semicolon will separate them into two instructions. So they will execute this part first and this part. So how to swap it? Right? You need to find a second variable, right? Yes. Third variable, sorry. Yeah, you need to define a third variable. And that third variable will keep one of the values. So let's do it. All right. Let me go to my office. Then, all right. So some of you are confused about the way I use Vim as my editor, but the way I use Vim, because it's much easier to show it in here, right? If you show it here versus showing some code like this, let me show it. Right, showing some code like this, it's not from visualize it. It's quite similar, but there are many more things around here. It's not easy to see. The reason I use Vim is because it's much easier to show it. So let me see. All right. Let me go to. Yeah, I can create a test.cpp, right? What I need to do is include some libraries. Indeed, I don't need it. No, I want to print. Yeah, if I want to print, I need to wait, IOStream, and yeah, there are blank space or no blank space, it doesn't matter. So we need to define some main function, right? Main function. Here are something I need to write into main, and I can define variables I equals to 10 and j equals to 20, right? Let's see what's the result. I equals to j and j assigned to I, right? Even if I write them in the same place, in the same line, let's see. Oh, I forgot another column. All right, then output, put a comma. Then j, and we can put an end line and return 0, right? Because I only use one hand, so it's a little bit slow. Why does this one keep showing up? It's visible, right? All right. So I need to SSH. How to do compile, right? Compile is easy. Wait, I haven't go to there. CD code. Document. Code. 6. Right. We need to do compile. Compile. This file name is test.cpp. dash O, we can output something like the test. Wait, oh, another, yeah. This compiler's error message is useful. Right, so I have compiled it, right? You can write some code. You need to compile using G++, and then you have compiled and then get an executable, which is a test. Then we can run this test. Can run this test, right? 20 and 20, as expected. What we can do is we can add another, let's call it temp, right? A temporary variable that will get something like first one. Let's put J to some guy, right? Let's temporarily assign J to it. Then J can be modified. Then I, yeah, can be assigned back. 10. So if we compile it, then run it again, we get swapped, right? So as you can see, if you want to change two variables, you need a third variable to temporarily hold the value of J before you modify the value of J, right? You hold it to some temporary place, then swap it, right? Any questions on this? No? All right. So input, we have already see how to do output, right? Now we want to go to input, but input is actually very complex. So if you go to some production softwares, always care about what the user gives you, right? If you are expecting some numbers, they might give you some strings. If you're expecting some strings, they might give you a picture, right? Something like that. So you have to always be careful about what the input will be given to you. What's the format, right? So the way you can read from keyboard is using std_cin, right? Another one is cout, output to the screen. And this one will read from your keyboard. And then you can put a variable name, and a variable names. You can train them together as you want to do the output, right? Input are similar. So if you want to input a name, then name, you can do something like this. So the purpose is to read the value for one or more variables, right? So in the future, we will learn what is the greater than symbol. It's another function or operator, actually. It will return cin, but it's a future story. So for this one, let's see our example. We have one example called what? Greeting, yeah. All right, this is the greetings. Maybe it's here for me. I should replace this. Let me put this one to the left side and this one to the right hand side. So here, right, this is our greetings. We're starting from some include libraries. This library string is for the strings, right? And we define the name as a string type. It's a declare some variables, right? And its type, it's a string. The variable name is a name. Then we first output something so that you want the user know what you are expecting to input, right? We said, please enter your first name. Then when they run it, they know, okay, I should input my first name instead of my last name, right? Then you can say, after they enter something, you can put the input into your name variable. And another way to define string variable is like this, right? Define a string variable and give it some initialized values, like this September. And you can give define some variable day, its type is integer, and give it some initial value, 7, right? As you can see, I was expecting to show this code last week. That's why I said September 7th, but today is 14, it's fine. And then we can see out. Hello, your name, and today is something. So as you can see out, right? As you can see how to use it. Let's run it the same way, G++. Greetings.cpp -o. Let's call it agree. All right. Then you can run it. Right. Please enter your first name. This is actually expected because we are first output this line, right? Then you can type in your name. Then it will output. All right. It may be not easy to see it. The screen is large, but I can hide something. So as you can see, when I enter my name, it will output saying something like, hello, Yang, today is September 7th, right? So here is what we are expecting. As you can see, you can do some scenes. So how about two of them? Not just name, we want first name and the last name, right? Please enter your name, right? We can input a first name, then we can continue input our last name. All right, we need to change it here. First name, then a blank space, then our last name. Right? What's the difference is now we want to input two strings. First one is first name, then a last name. So, right, so we will output. Let's see how it works. We need to recompile, then wait, then run it. All right, let me put it to the above side. Recompile it, then run it, right? Enter your name, right? I can enter my name, right? Then it will output, hello, Yang. Today is September 7th, right? It's running everything as expected. But what I say is, be careful about what we can input, right? How about we input something strange? Now these 4, right? It can still accept 4 as a string, right? It can treat everything as a string, actually. How about another one? You didn't specify, okay, please enter your name in this way. I can enter my name like this, right? It's valid sometimes when you are typing your name using comma. Nothing happens. Right? What's wrong with this one?
It's waiting for the second input.
Yes, correct. It treats the whole thing as your first name, then it's still waiting for you to input this last name, right? So be careful about this one. So you can input AAA. As you can see, it becomes hello, Yang. AAA. Today is September 7th. That's what I'm talking about. Be careful about the input format. If you are expecting the people to enter something like separated by blank space, tell them, right? You can say enter your name, something like in this way, right? First name, blank space, last name. Yeah, you can give some hints to the user, right? Ask them, don't use a comma, don't use something, and doing everything. Ask the user to do some format that you specify. But still remember, the user don't have to listen to you, right? You cannot expect the user to do exactly the same thing as you expect, as you specify. You have to do something like deal with what their input are. So there are many errors you need to deal with after you're getting this input. Any questions on this? No? All right. Again, this one. So some note, when we use cin for string variables, we will stop at the first blank space. So if you don't put any blank space, like the example, I use a comma instead of blank space, the whole string will be treated as one variable instead of two strings, right? And sometimes we can use something like a get line so that we can get the whole line from the user. And then we can define some functions to deal with what you can get, right? How you treat it, it depends on you. So normally what we do is like this. Oh, not this one, this one. All right, so from here, actually, I don't remember what's the syntax of get line. Let me search for it. C++, get line. All right. So get line is from input stream and the input stream and define a string variables. There are some examples. Get line stdce and put a string here. All right. So here is how you can search for result. All right. Sometimes I will forget what's these definitions. So instead of doing this, what you can do is, let me comment for this one, and let me input something else. Get line. Is it std get line? Yeah, get line. We already have std, so we can put a c in here, then f name. All right. So yeah. All right, let's see how it will run. Compile, it works. And we run. All right, I forget about the format. Let me input something like, right? It can capture the whole thing. And let's try another way. Let me clear it. Run it. I can do something like this, right? I can do something like this. It all depends, right? You can do anything. As long as you put everything in one line, it will capture the one line. Whether you use blank space or you use comma, as long as you don't hit the enter, it will capture the whole line. So this is the get line. This is sometimes useful, especially when you cannot be sure about the input from the user. Right? If you are the user, of course you know how to write down these formats. But if you don't know, then you can get line first with the whole line, even though they can do something like right? Sometimes you will get some extra things from the users. And after that, you can define your functions, how to deal with the remaining garbage, right? You can delete them, you can do with it, you can format your name in another way, but we will get there when we are talking about strings, right? Is it clear? What's the difference between cin and getLine? All right. So here is the input. We already see this example. Let's skip it. So after we define some variables, it's actually not useful for now, right? We just assign new variables, assign variable to variables. It doesn't make sense. We need some arithmetic operations for integers. We need plus, minus, multiply, divide, and module. Right? And here are some compound arithmetic. So if you want to say y increment by x, y equals y plus x, it means increment by x. You can say y plus equal to x. It's very common. You can see this type. And similarly, when you want to do minus x equals x minus 5, you can do x minus equal 5. So these are just some notations, right? It's not introducing something new. And also divide and multiply the same. If you want to do price, multiply by unit plus 1 and assign it back to price. You can do price multiply equal unit plus 1. And there are something more, right? We said I equals I plus 1. How can we write it? 1. Yes. I plus equal 1. And we have, it's still a lot of typing, right? We have something more, like the plus plus, minus minus, right? Because these kind of operations incremented by 1 is very common, especially in a loop. We will talk about maybe next week about loop. So you need to increment these variables by 1. It's so common, we use some new notations so that we can reduce the typings. So these are the post what is it? Post prefix? No, post prefix. These are called prefix. And this is the increment or decrement. So there are some difference between these two. Let's use it one example, all right? Assuming first we define some variable I, it's an integer, value is 10. Then we say, okay, how about we assign I plus 1 to j? We can write something like this. J equals plus plus I. What's the value of j? 11. What's the value of I? Yeah, 11. So when you say this is a assignment, right? We say assignment, we do evaluation first. We do evaluation on the right hand side. So plus plus I is evaluated first. Now I becomes I plus 1. So I becomes 11. Then we assign it back to j. Now j becomes 11 again, right? So how about next one? K assign j plus plus. What's the value of j? 11, 12. Yeah, we execute one by one, all right? So before that, j equals to 11. Now j becomes 12. What's the value of k?
11.
Yes. All right, you guys know a lot. So if you put plus plus to the right hand side, this j plus plus will return the previous value of j. If you say plus plus I, it will return the post value of I. So it's different, right? Plus plus and in front of I and the plus plus, after this variable, they are different. For this variable, they are the same because they increment by 1. But the difference is your return values. The previous one, the return value is I plus 1. The next one, the return value is j. So that's the difference. So here, I shouldn't say always use, but I would suggest to use increment, prefix increment, which is this one, plus plus I, and the minus minus j, and minus minus I, instead of the postfix, because this prefix will save one operation in CPUs. So it's maybe you guys are not familiar with how CPU works. So here is how CPU works. If I say k equals j plus plus, it will temporarily create another variable that will store the old value of j, right? Because we said right hand side evaluate first. So when we evaluate this one, we will first store j's old value to some temporary values. Then we increment j. Then we return this temporary value to k. So that's one more step. How about this one? We increment I by 1, then return I to j. Right? So no problem. But for the postfix, it needs some temporary location to store the old data of j. So whenever possible, use the prefix. But sometimes when I'm typing sometimes I also forgot. I just use the prefix, no postfix instead of the prefix, but doesn't matter. It's you will see that. So it's only very slight difference, but that's my suggestion actually. Yes.
If I want and J equals to I plus 1 and I is still 10, so how can I express?
Yeah, so don't use this notation.
Do we need to search?
No. If you are, so your question is, if I want J becomes I plus 1, but I keep its old value, right? So just write J equals I plus 1, right? If you want I to keep its own value, J becomes I plus 1 using this simple one. Whenever you use this kind of increment or decrement, it means you will change the value of I, right? Whenever you say I plus plus or plus I, you will change the value of I. If you don't want to change the value of I, do not use it. So sometimes you will see some of the weird notations, right? Let me show you some of the weird notation. This one. J equals I plus 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 1, right? Some weird things people might write it like this. It's even weird if it's another variable k, right? J equals I plus 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 k. Yeah, never write code like this way. Yeah. It can still, I believe it can still execute, but don't write it in this way. Any more questions? All right, even though I said don't use it, I will ask you a question since you don't have any questions. So assuming day equal to 7, int k equals day plus plus day. What's the output of k? What's the output of day? What's the output of k? Day equal to 7. What's the output of k and what's the output of day? Mm-hmm. 17? 16? It should be. It really depends. Right? It depends on who will be evaluated first. If the right hand side evaluated first, day becomes 8. Then here becomes 8 plus 8 equals 16. If the left hand side evaluated first, this one returns 7, but day becomes 8. Then plus day 7 plus 9, so still 16. Right? The answer should be 16. Let's see. Let's put another. Okay, put another here. Yeah, let's say k. Instead of day, let's say k. Where's my compilation? My name is PAA. All right, 16, right? Whether you evaluate the left-hand side first or right-hand side first, it doesn't matter. But there are some cases there will be difference. But anyway, as long as you can understand this line, it means you already understand what is prefix and postfix of plus plus, right? Sometimes we use this kind of exercises just for you to better understand the definitions, but never write your code in this way, right? All right, so some exercise, very simple one, how to compute the total values of all coins. Assuming you have a bunch of coins, of course, these coins are from US. I copied from the textbook, yeah, because their coins are more complex, such as they have penny, which is $0.01, dime is $0.1, quarters are $0.25. If you have X pennies, Y dimes, Z quarters, it equals 0.01x plus 0.1y plus 0.25z, right? If you formulate it using some equations, it will be easy. So the question is how you can write a program that will accept the user to give you the numbers for penny, numbers for dime, numbers for quarters. Then your output will be return the total values of all coins. Right. I will give you less than 1 minute to think about it. You can take out your pen to write it down. And then we can see if your what you write is exactly the same as mine. So just write down the key component. So your input are 3 numbers, actually 3 integers, right? Because the number of pennies cannot be 0.1. The number of pennies are 1, 2, 3, 4. And the same as dime and quarters. So input is 3 integer numbers. The output, what the type of your output? And you can practice writing code in pen, in papers, or that would be something from the exams. Right, I believe most of you have got the key components. Let's see, here is the solution. So you will define 3 integer variables: the number of pennies, the number of dimes, and the number of quarters, right? Then you output some message to the user saying, okay, please input the number of pennies, dimes, and quarters, right? You have to tell them the number of pennies, dimes, and quarters, otherwise they may input the number of quarters, dimes, and pennies, then the orders will be changed. So all you can do is, okay, I use one line saying, input the number of pennies, then seeing pennies. Then you use another line saying, input the number of dimes, then you get the dimes. Then you have another line, see out the number of quarters, then you can say seeing the quarters. So, but here, because the page is limited, I just using this way. And then you can see in, right, 3 integer numbers. And then the question is, how can we compute the total values, right? We have introduced the arithmetic operations, multiply, plus, right? You can multiply by its values and adding them together to get the total dollars. Then you can see out what the total value is, something, right? Any questions on this? No? Let me see if I have the program. Yeah, I should have a coin. All right. This is the program. Let me see how to compare it. Coin.cpp minus O coin. All right, let's run coin. So it asks you to input pennies, dime, quarters, right? What you can do is, okay, I want to try something weird, like these 0, 0, 0, right? You have 0 pennies, 0 dimes, and 0 quarters. So our total will be this. It will be fine, and you can try something like 1, 2, 3. You can test using some input and to see if the value it's computed matches the values you computed on paper, right? So that would be something that's normal input. So how about some abnormal things, right? -1, -2, -3, right? You have -1 pennies, -2 dimes, and -3 quarters. Your total will be negative. Sometimes we want to avoid that. How can we avoid that? How can we avoid that? In addition to integers, we also, unsigned int, right? And define these numbers are unsigned. So it will be different, but some more weird things will happen if you use unsigned. Unsigned. No, unsigned. Unsigned int. All right. Let's compile it. Let me clear it. Clear. Point. All right. -1, -2, -3, right? You have more weird things happening, right? Yeah, some of the weird things will happen, especially when you are doing. So last time when one student asked me, okay, what if, what are the things that happening when I'm doing something like overflow, right? If a floating point number can only support this range, if I give a much larger values, right? That's because these values are converted into binary first, then it are converted to some unsigned integers. So that's when you will get some weird values. All right. Questions? No? Easy to understand? Let's see later. And how about we say input A, B, and C? What will happen? All right, you have 0 pennies. If I input A, B, C, and blank space, you have 0 pennies, this amount of dimes, this amount of quarters. That's why I said careful about user's input. It will give you some weird numbers. All right, don't, for now, at least for now, don't care about the exact numbers because that's something that you need to understand about the binary representations. All right. So for this one, yeah, I believe is that clear enough? All right, let's continue. So in here, right, what's the correct format? Can we say 1 blank space, 2 blank space, 3? It's okay, right? We have tried. How about 1 tab, 2 tab, 3? Tab is the tab key, right? You know that? Yes, the tab. It's sometimes it's 4 blank space, sometimes 8 blank space. It's fine. We can try it. One tab, 2 tab. Wait, it's not showing. Yeah, it's too. Oh my god. Yeah, it's actually accepting, but it doesn't show it in here because the window is too small. So using tab is fine, and also you can try it using new line. It's okay. 1, enter. 2, enter. 3. It will also accept the correct values. So these are the basic right ways for your input. Do not use the commas, right? Sometimes you are getting used to 1, 2, 3. Don't use that. You can try more things, right? Try it. 1, 2, 3. Let's try. So actually, in the textbook, they also include this example. What is 1, 2, 3? Right? 1, 2, 3. It says it has 1 pennies, 0 dimes, and a large number of quarters. Right? You can try it. And how about some floating point numbers? You can also try it out. So the input, right? We have about the input and what are the more things about operations. First one is the round-off errors. So if we calculate, right, 1/3 to 2 decimal places, you get 0.33. You lost the remaining, right? 0.3333, a lot of threes. So you almost lost 1/100, right? Yeah. And multiplying by 3, you got 0.99, not 1. I mean, this one is computing by hand, right? If you are computing by hand and you lost the sum of the round off to some of the places, you got this. It also happens in your computer. So in the processor hardware, everything is represented in binary. So in binary means it has 0 and 1s, and it has a limited size. Remember we said, whenever you declare a variable, the compiler will allocate some space for you, right? It's either 34 bits, 64 bits. That's the amount of that's the amount of bits you can get. But our number systems, especially for the floating point numbers, they are continuous. They are continuous. But if you represent everything in binary with 32 bits, the total number you can represent is 2 to the power of 32, right? It's like you are sampling from the continuous space, continuous number space. So what you will get is limited precision. And errors may accumulate when you do more and more operations. Yeah. How about this one? Right. First, we define some variable x equals 4.35. And then we define some integer that's calculating x multiplied by 100. Right. If the x is precise enough, the integer n should be 435. However, if we output this n, we will print 434. So this one, let me see if I have code for that. Let me check that. Do I have one? I just, no, I don't have it. All right. Any questions? So the CPU-friendly operations are actually not multiplied. If you learn in the future, the CPU-friendly operations are multiplied by 2 to the power of something. That's basically some of the bit operations. So when you are multiplying by 100, 100 cannot be, it's not something like the shift operations. So we will talk about shift later. Right. This kind of doubles, remember doubles. These floating point numbers, integers are, most of them integers are correct, exact. But for doubles, there will be errors. Right. So divisions. So divisions are somewhat complex. So let's see, using examples to tell you what's the complex thing. So how about the first one? 1.0 plus 4 divided by 2. What's the output? 1.0 plus 4 divided by 2. 2? The left hand side is 5, right? Yeah. 5 divided by 2 is 2.5. Your CRD is 2, right? Okay, let me try it. I need to figure out. All right, let me see. Maybe you are correct. Let me see. I should close it, put it here. Let me show it here. All right, let me delete them. They're annoying. This one, let me compile it. Your output is 2. My output is 2.5. Did you input 1.0 or 1? 1.0? The output is 2? All right. Yeah, that's weird. So, so there are, yeah, maybe some standard difference. All right, so let's just focus on this one. This one is what I learned actually, and also I think it follows at least the Linux. In Linux, when you are adding a floating point number with a integer, you will get a floating point number. Yeah. So you will get 5.0, and when you divide 5.0 by an integer, it will get a double instead of an integer. So could you please try this way? Could you please try 5.0 divided by 2? You can try it. You can try it and see if this one getting 2 or 2.5. All right. It should give you 2.5. Yeah, you can show me after class. So that's that. So how about the second line? How about 1 plus 4 divided by 2? Yeah, that's 2 for sure. Because if there's no floating point in the equations, everything will just be integer operations. So 1 plus 4 equals to 5. 5 divided by 2, it will convert it into some integers, and it will always returning 2 instead of 2.5. So that's the difference. How about next line? The third, 1 plus 4 divided by 2.0. 2.5, right? So the rules are actually simple, right? If both numbers are integers, then the result of the division will be integers. You are operating on the integer divisions. If at least one of the number involves floating point numbers, the result is a floating point numbers. Let me try the remaining ones. Let's see this two. Let me compile and run it. Right, as expected. Only when all of them are integers, you will get integer output, which is 2. And for all the others, because of 5.0 is here, 2.0 is here, the output is a floating point number. So the output will be slightly different. So actually in Python, I believe, they define the 2 different operations. Maybe in the current version or previous version, I don't remember. They define something like 5 divided by 2, right? They define it this way. And another operator is 5 divided by 2. That's Python, not C++. They define 2 different variables, 2 different operators for division, so that one is floating point division and one is integer division. But in C++, we only have 1 division, and there's only 1 rule. As long as there's a floating point involved, it's floating point. Any questions? Here. So we have another operator, which is the modulus, right? If you divide 7 by 4, you get 1. How about you get the remainder? The remainder 3 will be returned to you by this percentage operator, which is the modulo. 7 module 4 equals to 3. So it will be sometimes useful in your operations. So in a math, A mod B or A mod n, the output would be something between 0 and n minus 1, right? Even if A is a negative number. Even if A is a negative number, this modular will be between 0 and n minus 1. But it's not true in C++. In C++, if the first number is a -1, the remainder is also -1. So that's slightly different. Have to be careful about this. So what if this n is a negative number? A mod a negative number. How about 7 mod -4? What is 7 mod -4? Let's try it out. 7 mod -4. We can try another one is -7 mod 4. And we can have 7 mod 4 as comparison. Oh, yes, it's a dividing. It should be mod. Compare it, run it, right? It's 7 3 -3 and 3. So the first one is 3 as expected. Second one, as I said, it will be different from the map. It will be the same sign as the first one. Last one is the same sign as the first one. All right. Some of the useful functions, you will use it, especially when you're doing some of the engineering equations, want to do simulations and so on. You can use this kind of functions, right? Floor, which is the largest number less than x. So if x is 1.1, floor is 1. Ceiling, which is the smallest number greater than x. If x is 1.1, ceiling is 2. And we can do round, right? Round it to the nearest integer. And also we can do absolute values, right? From negative number becomes positive number. And then we can have square root. We can have power, x to the power of n, x raised to the power of n. We can do exp, right? E to the power of x. We can do sine and cosine. They are here. You can use them. And with these functions, right, in the future, if I ask you to do integral of some functions, it will be very easy. You can utilize them, right? We will do that later. Exercise, write down this equation for this quadratic formula, right? Ax to the square plus bx plus c equal to 0. How to get the solution? Here is the equation. I believe you guys are more familiar than me, right? Especially just after the high school. And then how to write it in C++. I will give you 1 minute to write it down. You will have two outputs, right? One output is plus, one output is minus. By the way, someone tell me that 1.5 hours of lecture will be too long. Do you prefer 2 breaks in the between or just 1 break? Why? No break. No break? How about this? How about 2? I mean, I think 2 is more. 2 is better. 1 break is better. No break. All right, let's keep it at 1. All right. Let's ignore for now. E squared is greater than 4ac. Okay, let's just assume b squared is greater than 4ac. How to write it down? All right, let me write it down for you. So assuming we have double, right? A, B, and C. We ask user to give us A, B, and C. Then we can have the solution. The solution should be a double. X1, right? X1 should equal to something, and X2 should equal to something. And let's see out. See out X1. Give it a new line. Then X2. Give it a new line, right? So how to compute X1? It should be something divided by 2 times A, right? It's negative B plus square root of, yeah, we need a math. Include C math. I believe SQRT is also belongs to STD. Let's try B squared. B squared can be B times B minus 4 times A times C, right? Something like this. Let's do the same for X2. It's minus, right? There should be something like this. Let's try if it can work. I'm not sure about that. Compile, run. It's waiting for my input. Uh-oh, yeah, it's because the B square minus 4AC. Let's see. 1, 1. Yeah, right? If my input is x squared plus 2x plus 1, the root should be -1 and -1. I hope it's correct. So here is how to write it, right? You can do something like this. How can we improve it? How can we improve it? Yes, yes, correct. So square root is actually a time-consuming operation. So what you can do is you can store temporary, store something in a bubble, call it, yeah, ST, anything. And then you can put, all right, because I only have one hand. You can put this one, right, in here. So the temporary stores the result of the B square minus 4AC, the square root, to ST. Then you can replace this part by ST and also this part by ST. There are two benefits. One is you don't need to type it many times, right? And it saves some time. The second one is if you write it down twice, it increases the risk of typing it incorrectly, right? Sometimes, for example, in the first time you square root of b squared minus 4ac, the next line you've made a mistake saying square root of b squared plus 4ac. Right? If you store it in somewhere, you can be sure as long as this one value is correct, the others are correct. So sometimes it's good to have more variables storing these temporary values. Any questions on this? No? All right, let's continue. We have relational operators. Whether two numbers are equal, whether two numbers are not equal, greater than, less than, greater than or equal to, less than or equal to. So here are some examples. First one, we are asking whether 1 and 2 are equal. So the output will be false, right? So everything of these relational operators, the output will be either true or either false. The second one, we're asking is 1 less than or equal to 2, right? The answer is true. And also next one, 1e2 is actually 100, right? Equal, so they are true. And then we're asking whether lowercase a not equal to uppercase a, so the answer is true. And also we can ask whether a, lowercase a is greater than uppercase a, is this true or false? How can we compare two characters? Yeah, we ask the ASCII code, right? 97, 65, whether they are greater than. So same way. And also we can compare true with false. They're not equal. All right, I believe that's a perfect time for a break. We will come back at 10:30. I will leave 3 more minutes so that you can ask me questions.嗯。
前面有个 using namespace std，
对，
是只要把那个输完，后面就都不用输 std 两个盲盒。
对，是的。
好的，然后还有刚刚那个 day 加加和加加 day， 我试了一下，如果这两个反过来的话，结果就是不一样的。因为如果你先输了这个，它变成8的话，后面就是8加9是17。一个
不会。
是的。
加加 day 加上 day 加加 day 加加 return 了8啊，不是，你先输这个对吧？
对
，day 17 return 了8，对，但这个也是 return 8，
但是它是8加1对。
哦不，它先 return 了8。
但是我试了一下，
真的吗？
是不一样的。
等一下啊，我看一眼。
那 day 加加和加加 day。
我随便来一个，k 等于7，然后这个等于什么？加 k 加上这两个加上 k 加加这样的是吧？看这一题不是。算一下啊，加 k 的话 ，k 变成了8， k 变成了8，对。
8加9等于17。
但是它应该是return了。
这个相当于把 k 又复到了8这个值，然后就在8这个基础上再加，对，就是8加9。
因为它应该是
它这个
它这个负的是它前面就算一个式子，然后再加后面这个。
是。然后
这地方我讲错了，是。
如果定义一个 int a，那不管这个是2.0除以几，就是不管它有没有 float，它都是整数，对吗？
对，是的。
好，那这个为什么它就相当于直接忽略了？
差不多，基本就是忽略了它，对，跟着前面那个符号来。
好的，好的，谢谢。
我想问一下，就是 STD 冒号应该在什么时候要用的？
哦，就是这个是吧？
对，冒号。
对，
你们可以这样子，但是如果你们到大公司去的话，他们是要求所有都是 STD 都要留着，都要留，因为他们会定义自己的 namespace，就是以后你们写自己代码的时候哈，一般比如说写自己代码，可以有多个 namespace，可以定一个 namespace，比如说我定一个我的 namespace，然后在这个里面我写了一大堆的代码，比如说我定了一个，这是以后的事情啊 ，class A，然后在下面的时候我要用 A 的时候，我就会说，比如说会叫这个点 A，就是这样子，以后就是这样子。对，
就是那我其实最好的处理方法是在比如说 double int 这种符号前面都加 std 冒号。
double int 是不用加的，他们是不用加的。
我到底在什么前面要加的？
哦，就是要加的原因是因为cout 是定义在 iostream 里面，他们是一个iostream，它是一个库。对，这个库呢，它写了刚刚那一句话，就是 iostream 里面呢写了这样一句话 namespace std， 然后定义了一个叫做比如说istream， 定义一个叫做 istream 的东西。然后 istream 里面呢又有一个就叫 cout，然后所以这个时候你要用 cout，你就必须要用 std 冒号冒号死。就是这样子
，iostream 还是 istream？
对，iostream，它有一个叫 istream，一个叫 ostream，其实它应该是属于 ostream，就是这个后面会学到，就是 namespace 大概是这么用的，就是你为了不让你自己定义的东西跟别人东西混起来，就以后你可以定一个自己的 namespace，比如说你自己的 namespace，这个 namespace 里面你可以定，比如说一个新的 ostream，然后定一个新的 cout，这个时候你就可以用，比如说。这个点 cout 这是没有问题。对对对，
我明白。好笑。
谢谢。
我的那个为什么4.35乘100，然后复数的是434呀？
哦，这是因为它有个误差在里面。
为什么误差正好是1？它的原理是什么？
不是正好有，就是这个可以比较复杂一点。
为什么不是436？为什么434？
好，这个如果你想要知道的话，是大概这样子。什么？这里我不知道它支不支持小数。这个叫做4.34，我看看啊，就是它会表示成这样一些二进制的数，然后它乘以100以后，它又是一个二进制的数，然后算完以后呢，就是说它这个数字肯定不是完全代表了，比如说4.35或者4.34的，它不会完全代表这个，然后它就会有一个误差在那，但它为什么具体误差是1？
因为
这是运气
成的是吗？是二进制才那个背后的那个吗？
就是计算机里面都是用二进制乘，
是
二进制的话不是后面加0吗？就是
不完全是，就是它没有完全表示。你看着4.35在10进制里它是结束了，两位的那个精度就够了，但在二进制里面它需要无穷位才能够表示4.35。
所以它是二进制造成的这种误差。
对，就是你觉得在10进制里面可以表示完的数，它在二进制里面不一定能表示。
那有些二进制里面也能表示完的数，是不是乘100就没有误差？
对，就没有误差，是的。
刚好是
啊，这个是运气，刚好就是运气。你不知道它误差是多少，你只能说它可能小于某一个数，比如说。
modulus 是什么意思啊？
求余数啊，
求余数。
对。
那个大 A 为什么等于65？
啊 ，ASCII 码 ，ASCII code。
为什么 A 小于 A 大于？
这张 ASCII 表上回给你们看过了，对不对？看有没有
在这上面它那个数是更大。
对，就是这上面的数，这个看得更清楚。
那我记得咱们在那个叫什么，不是16进制里面，那个大 A 不是表示就是1、2、3、4、5、6、7、8、9，然后大 A 表示
这个跟那个不一样，这个 A 呢是一个字符 A，就是国际上为了传输字符呢，它都表示了一个数字在里面，比如说 A， 它就表示数字65。然后小 a 在97在哪里？小 a 在这里，小 a 就是97， 这是国际上通用的一张表。这张表大家在传输
那
报啊，
什么时候用？这两个怎么区分呢？就是那个16进制的和那个
大部分时候你不用16进制，大部分时候你只看这个。除非他强调了这是16进制，不然任何时候都是字符串。
然后还有那个 C 印的 guideline 那块是什么意思？
就是 C 印的时候遇到
我输一个那个 C 印，我输一个这个 guideline，然后打括号就是能把
整行读进来，叫
整行读
get line， 一整个 line 读进来。
那上面这个 using C in for
C 印的话，
一个一个来。
对你打了一个空格，它就结束了，它就进入了。
C in 的话，它
get line 它就整行
一个箭号那个。
对，是它有
这个 stop as the first 就是
base 就是空格，空格，任何形式的空格。
你可以不要硬件交付电。
可是老师，你刚才说你刚才打那个这口在打那个名字的时候，那个 first name 和 last name，然后
你问他的，
我看这块，
我再问。
不在这
我之前试了一次，
找一下，
好久以前试过一
就
次。
这会儿 first name last name，然后你刚才就是输了一个就是加 first name 和 last name，但是你输了一个就是加一个逗号，
对，
他为什么他不行？
因为他读的时候一定要遇到空格才会结束。
那他这样读的话，他光读成 first name，
他把全部读进来，如果空格加进去，它就变成了一整个都是一个 string。
那 first name 和 last name 它也没有区分。
对，没区分开，因为你没有告诉他逗号是区分符，他认为逗号是你名字的一部分，你的名字里有逗号。
如果就是说我只定义它这个 first name，但是我在填的过程中出了一个空格，然后再写一段的话，就是一整个都当做。
对，就是它以空格为区分，凡是遇到空格，它就认为新的数。
那这块 sin 杠杠 free name 是 free name， 然后遇到空格就后面是 last name。
对，是的。
那咱们也看不出来这是它输入有什么区别。
还是有区别，你可以自己回去试一下。你如果不加空格，你回去玩一玩。
那加空格后面他也没告知你后面是 last name，他就是输入之后，
他就把它保存到那个 last name 里。
那你这个 L name 就相当于就是可以代持那个 last name。
这个就是我定义那个变量，我自己定义那个变量，对。
老师，那个435它怎么做，就是能让它避免这个问题？
你就是不要用 int 乘法。用 flow 的乘法，然后尽量保存的多一点，多几位，因为 int 本身精度就省时掉。
对。
但是它保存起来不一定435，可能是434.99999几也是有可能的。对。
就是我想问，就是那个，就是曲模运算和曲余运算有啥不一样？
曲模跟什么？曲余就是曲余，就是曲余。
一样的吗？
就数学里面的曲余的话，它就是。比如说你对4取余，它永远是0到3之间嘛，对吧？
对。结
果要不是0，要不1，要不2，要不3，但是它有可能是复数。4++里面有一个区别，就是有个复数，其他都一模一样。
那就是在复数的时候，它有啥区
别？
就是如果是数学里面的曲余，如果input的是一个复数，即便是一个复数 mod 4，它也是0到3之间，它不会是一个负3。这个是数学里的定义。对不对？
刚才不是说那个他取的那个余数，然后会跟他的
对，这是 C++ 的定义。C++ 定义是跟前面那个数的符号一样。
行，
跟前面那个
对，跟前面那个符号一样。
老师还有一个，就是那个啥，就是那个 event 什么的，然后就是如果输入 cd 点点回到 home， 还有 cd 这个波浪线回到 home， 它回的 home 好像不是一个 home。
是一个 home，点是指父parent。不是说 home，
我知道，就是回到上一级。
对，
然后
点是回到上一级。如果你有很多级的话，点是回到一个上一级。tilde 是直接回到了最终的那个 home 这个位置。
怎么说？
就是怎么说啊？你可以回去理解一下。
好吧，谢谢了。
尽量照顾到所有人。
OK。
这个是
Last week I was in your conference.
Okay.
I wrote to you.
Oh, yes. Wait a minute. Are you talking to me?
I wrote to both of you.
Yeah.
I can get the email one second.
Yes. Okay. I will.
List file 就是把那个文件你 还有一个问题就是
嗯，
我用 VS Code 写的时候，然后我要就使它运行的话，我会打开一个 terminal 嘛，对吧？
不用打开 terminal，你可以直接运行。
啊，
这个 error，
这样
我不知道它是为什么。
写 run
那
吗？不是吧？
不是，你要安装一些 extension，你可以在这里直接 run 了以后，你可以在这里写，对不对？
哦，安装一些。
对，安装一些 extension。extension 里面有个叫 C++ run。
我知道。但是比如说我是已经安装了 G++ 那些的，然后我在下面就是按那一套走嘛，就是 G++ 什么的，
也可以
然后那
也可以
样子。但是我发现就是原本是点杠，然后直接写那个 exe 的名字，但是它
在
VS Code，
Windows，
对，我是 Windows，对，
嗯
我跟你说。但是它实际上它需要多一个后缀，就是上面
exe 对吧？
对
对，这个是乌班图跟Linux 跟 Windows 的区别。
我就说，
是的。
那没问题。
最后那就是那个 case 11是吧？然后这变成了12。我查了一下，它是那个就是先赋值再加还是先加再赋值的区别？
对，是的。
Right, you sign here, not
okay.
not my super.
Right.
Yeah.
Okay. Let me erase the next one. Sorry about that. All right, so let's continue our class. So for relational operators, we have this, and these operators are actually quite easy to understand, right? Equal, not equal, less than, greater than, and so on. So we have logical operators. So what's the difference between relational and logical? So relational will output true or false. Logical will also output true or false. But this one is comparison, right? Compare whether two numbers are equal. But this one are connecting two of these relational operations. For example, if you already have an expression such as a greater than b, you can say, is it not a equal to greater than b, right? It's called logical inverse. So if your original expression evaluates to true, it will become false. If initial is false, it becomes true. So it's called the logical inverse. And we have and. So and is only true when both operators are true. So we have a and b, right? This is the equal two expressions, and if you want to combine them into one, it's like this. If it's true, becomes true. Anyone is false, becomes false. And we have an or, right? As long as one of them is true, becomes true. And it's only false when both of them are false. So here are the logical operators. So let's see, how can we write it? How can we ensure A is greater than B and B is greater than or equal to C? Write down this expression. A is greater than B. A is greater than B and B is greater than or equal to C. All right, let's go to here. So initially, for instance, we have a bunch of numbers, A, B, and C. We said for comparison, we can have A should be greater than B, right? And we have another comparison, B should be greater than or equal to C, greater than or equal to C, right? We write it in this way. So we have two of them, A greater than B and B greater than or equal to C. And we can have a logical operations like the and. This is how we express it, right? A greater than B and B greater than or equal to C. So here is how can we write it? So it will be useful when we cover the branches, right? If if else statement, case statement, we will see this kind of operations. Right? At least for now, you know, you need to know how to combine them. Right? So what's the result? We said Boolean values, right? True or false are Boolean values. Boolean values and integers can be converted, right? So we are asking, is 100 greater than 0? The output should be true, right? It's true. 100 is greater than 0. And how can we convert a Boolean value to an integer? Yeah, it's 1. We will get 1. When you do cout, it will output 1. If it's false, we will output 0. It will not. So even if you write it here, 100 greater than 0 in here, it will not output the characters like true or false like that. It will only output these integers, 1 or 0. So when you output a Boolean value, you need to see it's an integer. All right. So what's the result of this? I is 100 and j is I less than 10 and plus I. False, yes. Because this one is false, right? 100 is not less than 10. So what I want to emphasize is you can still put some expressions here, right? They will do evaluations on it. And we have something, did I put it here? No. So there are two differences, right? One is plus I and I, this one, and this one. There's something called the lazy evaluation. So whenever C++ knows the result, sometimes they will skip the remaining. Let me try the first one. Okay. No. Right? It's still 100. Initially, I is 100. We're asking is I less than 10 and plus I. The output is still 100. Convention here. No question on this? Yeah, it's called lazy evaluation. So because I is equal to 100, so the left-hand side, 100 less than 10 is already false. Anything end with false is false. So C++ is really lazy. When they know the result is false, they will skip the remaining operations. So whenever it sees it's false, it's done. So J will be false, and the I, this one will not do its operations. We can do something similar in here. Let's call it another name, int k. Replace it with k, plus k, and output k. Right? Yeah, it's 1, it's 2. So for the second one, So for the first one, because it knows the answers, it will skip the remaining operations. For the second one, when k equals 1, because 1 is less than 10, so the left-hand side is true. But whether t is true or false depends on the right-hand side, right? So it needs to evaluate the right-hand side. So k will be incremented by 1. So k is 2, but I is still 100. Any questions? Yes.
它这个如果是这样的话，那就是那个先判断了这个逻辑，然后再去输出那个加加。那如果我那个加加 k 就是在那个第二个东西里面加加 k 我输出等于1的话，那它最后是什么结果？就是因为我是先判断了与这个逻辑，再去输出加加 k。
It's not output plus plus, it's evaluate plus plus. Evaluate, so it's different from output. So I still don't get your answer. What's the...
就是我想
So you are considering about the second one, right?
对，如果它是先判断啊，我加加 k 后面会输出一个 k 的2的这边。那如果我加加 k 等于了1，那这个加 k 等于1，它是错误的。
What do you mean by
它就不会执行，它应该还是1。那如果它是2的话，它应该就会输出一个2。
Okay, you are talking about this one.
Yes.
Right? It doesn't matter actually, because your left-hand side will not, it's true, right? So you will still, and you will evaluate the right-hand side. As long as it's evaluated, k will be incremented. So the only difference is the output of t. Right? Yes.
So it is wrong.
The only
on that is wrong.
Yeah, you will evaluate on the left side, and whether you put something here or not, it only changes the value of t. It doesn't change the value of k. K will always be incremented. So the point is this, right? So if, for example, if I change this or to end to or, what's the output of I? Yeah, 101. Because the left-hand side is false. We need to, the output of J is not decided yet. We need to evaluate this one and decide J. So it really depends, right? It depends on whether the left-hand side can decide the value of the J or K or T, or it cannot. If it cannot, it will evaluate the right-hand side. And it will continue to evaluate the remaining. It's basically the orders. So C++ is lazy. That's, you can see, right? In other words, when it's some expression like this, whether it's less than 10 and greater than 50, whenever this one left-hand side has already decided its value, the right-hand side will not be evaluated. So that's C++. You can save time, and it will be more efficient to do the work, right? Any more questions? Try to use English. No? No one asked me, so I will continue. Another one that's yeah, questions?
I want to know what if this k equals 10 and
Equals to 10 and Okay. So how about this one? What's the result of k less than 10? True or false? It's a false, right? Because it's a false, so I don't need to evaluate the right-hand side. I know t will be false. K smaller than 10? Pardon? Oh, smaller. Yeah, smaller than or equal to. Yeah. Then the left-hand side will be true. Then you have to evaluate the right-hand side. Then it will be 11. What?
More than
Okay. How about in front, right? Right, is this what you asked? All right, so we will still do this first. So k will always be incremented, and then will be evaluated. So k will be incremented, k becomes 11, and anything not equal to 0 is true. So this becomes true, and you will evaluate the right-hand side. Right. Yes, question? K less than plus k. All right. You guys are putting more weird cases. K less than plus k, right? Do we think it's true or false? Yeah, I believe. So first, never write code like this. Then I believe this one should be true, right? What? Add an end statement. All right. Yes, is that what you asked? All right, this one is true. This one is, I believe this one is true because it really depends on whether you evaluate left-hand side first or right-hand side first. Yeah. Let's do one step at a time, not two steps at a time. We will evaluate this one. Let's say T1 equals this. Let's output T1 first. All right, let's see. It means it's a false, right? It really depends on you evaluate the left-hand side first or right-hand side first. If you evaluate the right-hand side first, now k becomes 11, right? 11 less than 11, it's a false. Right? Again, it's interesting to play with these guys, but never write code like this. Right. Any more questions? Okay, so one rule is anything not 0, that's true. Anything non-zero, that's true. So 1 is true, 2 is true, 3 is true, 4 is true, anything is true. Only 0 is false. All right, only 0 is false. When you convert integer to Boolean values, only 0 is false. All the others are true. Question? Yeah, it's called the precedence of operators. So plus actually has the highest precedence. So it will always evaluate plus first, then evaluate less than or minus than or greater than. Yeah, it's the same. All right. Oh, yes. Your question is different. So how about k++? We can do this on and on and on. So as we said, k plus plus is first evaluated. K becomes 11, and the right hand side becomes 10, right? So 11 less than 10, it should be false. It should be false. I think. Yeah, it should be false. Okay. You can try more things on that. So it really depends on the precedence. We will talk about that later. All right. So let's continue. Otherwise, I believe I won't be able to finish this class. So one thing very similar to logical operations and or we have bitwise operations. So here is the bitwise inverse. 1 becomes 0, 0 becomes 1. You can think of 1 as true, 0 as false, right? True becomes false, false becomes true. Similarly, we have bitwise AND operation. So remember, you do 1 ampersand or 2 ampersand, and that's different, right? 1 ampersand means bitwise AND, 2 ampersand means logical AND. So if it's bitwise AND, still you can think of 1 as true, 0 as false. The table are exactly the same as the previous one. Yeah. So it's 1 only when both of them are 1. And the OR is only 0 when both of them are 0. So that's basically the same. You don't need to spend too much time on it. One thing that's different is the XOR operations. So in bitwise operation, we have one more is called XOR. So this is this hat is XOR. So A XOR B means are they different or are they the same? So it's only 1 when they are different, right? If they are the same, the output is 0. So these are the basic operations. So bitwise operations are very close to the lower level details about hardware implementations. And we have another one called a shift. So we can shift the right, shift the left. If you convert everything into binary, then you will understand what does it mean by shift the left or shift the right. So the question is, why do we need bitwise operations, right? The main reason is bitwise operations are more efficient than any other operations because in CPU, everything is defined in binary. Yeah, everything is defined using logical gates, AND gates, OR gates. That's in CPUs. That's corresponding to the bitwise AND operation, OR operation, XOR operations. Everything has the underlying hardware implementations on it. So if you do that, that's very efficient. Right? What's the result of this? 110011 and 001100. It's 0. Yeah, it's all zeros. And this one, all ones, right? Next one. Yeah, the same as this one. Right? So here are some bitwise operations. You can also try that in your computers. So let's continue. How can we check if an integer number is even or not? What do we mean by even? Right. 1 is odd, 3 is odd, 2 is even, 4 is even. Right? Divided by 2, right? If the remainder is 0, it's an even number. 2, 4, 6, 8 is an even number. Odd number 1, 3, 5, 7. How can we check if an integer number is even? Mod 2, yes, you can mod 2, yes, you can mod 2, and you give the remainder is 0, right? Any other way using bitwise operation? You can check the last bit of a number, right? If the last bit is 0, it's an even number. If the last bit of your number is 1, it's an odd number. So how can you check if the last bit is 0 or 1? Plus 1. Bitwise operation. How many bitwise operations do we have? N, 4, XOR.
Did you share and one on
Which operator you use, and or XOR or not? XOR? Yeah, we can use XOR. And XOR with what? Yes. So I would first say the most simplest equation would be J and 1. Boolean, is it even or not? Right. We can use bitwise operation to end with 1. Yeah, if you can understand it, it means you understand what is the bitwise operation, right? For example, 100. Let's see how 100 can be converted into binary. You can check online. Do I have it? Yeah. When you convert a decimal number 100 to some binary numbers, it can give you something like this, right? What is 1? 1 is 0, 0, 0, 0, 0, 0, 1. And you add them together, it becomes all zeros. And how about a odd number, right? For an odd number, the last bit is 1. So AND operation, shift AND with bitwise AND with 1, the output is 1. So you will have either 1 or 0. And in this way, you can check if a number is odd or even. Right. This is just for you to better understand what is bitwise operation. But in your program, you should write mod, right? If mod 2 equal to 0, so don't use it to show off. It's just for you to better understand it. So in your code, you should write something like this. Right? You should write something like this. If the modular of 2, remainder is 0 or not. This is the way to check if a number is even or not. Right, let me see. All right, how to do what is shift operation? I want to show it to you so that you better understand it. All right, what is 97, right? I want to shift the layer by 1. Okay. Right, so for this one, right? What is bitwise shift? This is the bitwise shift. You want to shift shift I to left by 1 bit. Let's see the result. Wait, redeclaration. Right, it's 194. What's 194? What's the relationship with 97? Yeah, it's times 2. Right. So left shift by 1 bit. If you think about 97, it's this one, right? 97. Let me keep it. This is 97. Let's see. Yeah, what's 194? Right? It has 1 more bit. Let me put it here. This is the shift left by 1 bit. I should write it this way. Right. This is a bitwise shift. this is the initial value. You shift the left by 1 bit, and you put a 0 to the right hand side. So if you want to multiply by 2 to the power of n, you can shift by n, right? It's basically multiply by 2 to the power of n. So this is the bitwise shift operation. We can shift the left, or shift the right. Shift the right in the reverse. Divide by 2. So what's the benefit of shift? What's the benefit of shift? Yeah, it's efficient, especially when two very large numbers, right? When you multiply, and one number is very close to the power of n, right? If you want to multiply 1, 2, 3, 4, 5, 6, 7, 4 times 2 to the power of 20 plus 1, right? If you want to do some computation like this, some number multiplied by some number very close to the power of something, you can do is, how about 1, 3, 4, 4, 5, 5, shift the left by 20 plus 1, 2, 3, 4, 4, 5, 5, right?
Yeah.
They are exactly the same.
Yeah.
But these operations will be much faster than the previous one. But yeah, that's something when you are especially programming for something that needs low power and high efficient. Yes, questions?
I think you brackets between the left shift and to
Which bracket?
Really the brackets one, 2, 3, 4, 5, and 2.
Oh, yes. I believe so. Yeah, because the precedence of the operators, maybe yes. Yeah. Always include this kind of parentheses. If you forget which one will be evaluated first, right? Otherwise it will be left checked by this large number. Yes, thank you. So, all right, this is how you understand these shift operations. Right. An integer number divided by 4, how to do it? Divided by 4. Discard the remainings. How can we do integer divided by 4? How can we use bitwise operation to do divided by 4? Remember, left shift means multiply by 2, right? How about right shift? Right shift means divide by 2. So if you want to divide by 4, right shift 2, right? Right shift 2 means divide by 4. How about get the remainder of an integer number divided by 8? How to get the remainder? Get the remainder divided by 8. How to get this number divided by 8? What's the remainder? Remainder means, what is 8? Right, 8 is 3 zeros. So the last 3 bits are the remainder of 8. So what you can do is, if I want to know 1, 2, 3, 4, 5, 5, remainder with 8, I can do AND. What is 111? 111 is 7. Right? Let me use 194. 194, and with 7, what does it mean? It means 11, 0, 0, 0, 0, 1, 0, and with 111, right? It equals 0, 1, 0. So this is how you get remainder if you divide by 8, right? So there are many more operations you can do with these bitwise operations, but most of them are related to 2 to the power of something, right? If you want to multiply, divide, or get the remainder of something that has to be to the power of something, then remember you have the bitwise operations. But you don't have to remember that. You can always do the remainder operator. Again, what's the result? It's a bitwise invert, right? Of A. And you need to first figure out that in the ASCII code 97, convert it into binary, reverse everything, and shift the level by 3 bits. Right? These are the kinds of operations you can do. It may seem so weird, but yeah, it's everything is in bit. So you can also check out this bit set using this bit set from this library. So you can check out whether -5 is represented using 8 bits in your machine. But what I would suggest is you can Google that, right? How can I Google that? What I Google is convert decimal to binary, then click on any of the link, then you can type in the number and you will see the binary representation of the number. Any questions on bitwise operations? So in all of your projects, I believe you can ignore the existence of bitwise operations, right? You can most of your project you will never use bitwise operations, I would say. All right, so we have another operator called conditionally ternary operators. So most of the operations we have only include 2 sides, right? Left side, right side. But here we have a condition, then we have result 1, then result 2. So we will get the result based on whether the condition is true or false. So it's very close to what we will discuss later about the conditions of branches. So this, first we say month is 9. We say semester equals, if month is greater than 9, it means it's a fall semester, otherwise it's not fall semester, right? So the output will be fall. It's called ternary. So we have multiple choice, right? You have result 1 as choice, result 2 as a choice. And as well, you can put very complex things in result 1, very complex things in result 2. It will evaluate it. Similar here, right? You can combine them together. You can say semester equals, if the month is greater than 9, greater than or equal to 9, you get into fall semester. Otherwise, you still have 2 choices, right? If the month is less than 5, it's a spring semester. Otherwise, it's a summer semester. So you can combine all of them. You can combine more and more, but it's a bad style. You can. A good style is at most. So most of the time, you will use something like this. It's because you don't want to write something like the if else. We will discuss later. You want to use 1 line to do the work, but combining more and more is not a good behavior, right? It's good is not a good style. But as you can see, here is how we do it. You can evaluate the right-hand side, right? If month is less than 9, you will evaluate the right-hand side, and the right-hand side will be evaluated based on the month. If it's less than 5, do something. Greater than 5, do something, right? Any questions? Try to use this kind of conditionary operations. Remember, here's a question mark, right? This is the only place question mark will be here. We will cover more when we go to the if else. So we said many times there will be implicit type castings in C++, right? So which one do we prefer? The first one says A is a character, its type is character is assigned A, then we will convert A to an integer and assign it to B. Versus the same, then we explicitly write an integer int here. So int with a parenthesis, we mean a type casting, right? We tell the compiler, actually we're not can tell the compiler, we'll tell other programmer, right? When other people are reading your code, when they see these kind of things, they might get confused. What is A assigned to B, right? What is the one character assigned to another integer? Here it's easy to see, but in the future, when you learn class, inheritance, polymorphism, when you're assigning some type to another type, right? It's very confusing. So it's better to use explicit one. And C++ has a new grammar. So this is a C style, right? C++ style says we have some function called static cast. You are casting from one type to another. So the reason we put this one is because when you are reading code, reading other people's code, reading your own code written in the maybe in previous semester, then you can easily search for static cast to see, okay, this is a casting. Otherwise, if you search for int, right, many places will show int. But if you search for static cast, it always only means casting. So from the behaviors, these two are exactly the same. But from styles, the static casting will be preferred. And the reason R is more visible and its intentions are more clear to other people, especially someone who is reading your code. And it allows the compiler to do the casting check during the compilations. It will be more clear when you go to the class, when we talk about polymorphisms. And it will be seen when we talk about especially the pointers. So pointers is another nightmare. When it's a pointer pointing to an integer, it's pointing to a character or number, and you casting one by another. So that will be a problem. But for now, you just need to remember, if you want to cast, always use static cast. Questions?
It'll still work without the static cast.
Yeah, it still work. At least for some simple types, right? In the future, when we talk about inheritance and many things, it's better to use this. It's just a style issues. It's not the behaviors. Behaviors, it can still work. In many times, I would just omit this one. I'm too lazy to type this long function names. No more questions? Right, let's go to this one. It's the precedence of operators. Actually, when we write down something like, yeah, I have erased that one. When we write down this one, let me see if I can go back. Right, this one. You have to remember which one is evaluated first, right? Is it a plus or is it a left shift, right? So initially, if I write it this way, it's quite possible that if we have a tree, it's like left shift is evaluated later, the left-hand side and the right-hand side. How can I type it? It's bad because I don't have a blackboard to draw. Yeah. So it's a 1, 2, 3, 4, 5, 5. And the right-hand side is a plus, right? Then the plus, we have, it's funny, and yeah. So something like this. So precedence will explain what's the order of evaluation, right? If something like this, if this tree is given to me, sometimes we call it the abstract syntax tree, we will do a plus first, and we will get the plus of these two numbers, then we will do shift. On the other hand, if I put parentheses here, I won't draw it again, it's nightmare. But if I put a parenthesis, so parenthesis is always the highest order, right? If you put a parenthesis here, the tree will be different. The plus will go up and the shift will go down. You will do the left shift first, and then do a plus. So that's the precedence. So some simple rules. Arithmetic operations are always has higher priority than the logical and the bitwise operations. So plus arithmetic operations, plus, minus, divide, multiply, right? They have higher priority than the logical. Logical means greater than, equal to, or the and or. So in arithmetic, inside arithmetic, divide, multiply has higher priority than plus and minus, right? That's are exactly the same as the common sense, right? We have learned in class. And the logic operations comparison will be greater than, equal, or inequality is greater than logic and or, right? So here are some simple rules. Other than that, I couldn't remember the full list, but you can check that here. We have a full list here. Let me open it. Where is it? Yeah, here is the full order, right? As you can see, plus or minus has the almost highest priority. So if you write something like plus something, plus is always evaluated first. And then we have something like multiply, divide, or get a remainder. It's in here, and then we have plus or minus. So they belongs to the arithmetic operations. They have higher priority than the shift, comparisons, and operations, all operations, and so on. Right. So if you want to remember some of them, you only need to remember the arithmetic and these logic operations. They are priorities. As long as you know them, it's fine. For all the others, using parentheses, right? Which one you want to evaluate first, using parentheses. Using parentheses to control which one evaluate first. So what's the value of this? Two, yes. Because we evaluated the right-hand side first, right? The multiply and divide has higher priority than plus, so we will do 2 times 3 divided by 4 first. 2 times 3 is 6. 6 divided by 4 is integer division, so it's 1. And then we get 1 plus 1 equals 2. How about this one? One? Is there 1 or 2? Oh, which one evaluate first? Yes, left-hand side evaluate first, right? Arithmetic has high priority than the logic operations or comparisons. So it becomes 4 greater than 2. It's true, or we can say it's 1. How about this one? Right? We said plus has highest priority, so plus will be evaluated first. It actually doesn't matter, right? Because it couldn't be plus. I divided by 2 is not a variable, so it will always combine with I first. More complex ones, right? This kind of things. Again, don't write it in this way. Using parentheses. Using parentheses to combine 1 and 1 and 1, right? It becomes 10 greater than 3. It's true. Then 4 greater than 2. It's true. Then is it start with and or is it start with equal comparison? We don't know, right? So it's always bad behavior, bad style to write something like this using parentheses. But if you want to find out, try it in your computer, I cannot remember the result. I cannot remember the orders, actually. You don't need to remember it. For readability, enclosing all the sub-statements with parentheses, right? You want which one to be evaluated first, using parentheses. Next, we have constants, right? Remember the program we have written. Oh, wait, let's wait for that. Okay, constants are, so variables and constants are actually two different types, right? You can think of they are two different types. So for this one, this pi, we say it's 3.141915926. This pi, because it's a constant, we don't want anyone to change it in your computer, in your program. So you can define it as a constant. So after you define it as a constant double, right, compiler will allocate some space for you that help you to store the value of 3.14, put it into some memory space, then give it a name called pi. Then after that, no one can change pi. It's a read-only copy. Right? No one can change it. It's a read-only. It's different from constants, actually. It's just a read-only. We will see the difference maybe in many lectures later. So the benefits is give some symbolic names to some of the constants so that the program will be easier to read. So instead of, for instance, putting pi in here, we always using 3.14 in our program, right? The first line, like we can write something like, all right, let me delete them. We can say double R equals 2.8, right? We can say area, double area equals 3.14 times R, right? Here's how to compute the area of a circle. Right? You have the radius, you compute the circle. Then the question is, if you always write something like 3.14, right? People might get confused. What is that? For most of you, you know what's this, but yeah. So the best way is define a constant. Double, you still need the type, it's double, then pi equals 3.14, right? Then you can replace everywhere with a pi. So there are a few benefits. One of the benefits is if next time you don't want to use 3.14, you want to use 3.14, what's next? I don't remember. You want to use 3.1415, right? You can modify it only once. Then every place you use the name pi will be changed instead of changing everywhere. And it also gives a meaningful name, right? People knows this one is the pi. And it allows the compiler to do better checking, especially if you're trying in some place, you're trying to modify pi, compiler will know. It will give you some compiler errors. Right? It will complain about you modifying this pi. Any questions on this? No? All right, so remember our computing total dollars, right? We divide by, we said 1 penny is $0.01, a dime is $0.1, a quarter is $0.25. So we can convert it in this way. Or what we might ask is, how can we remember these names, right? Remember these numbers. We can replace them with some constant numbers, right? Constant number, pennies per dollar equals 100, right? We need 100 pennies per dollar. Or we have, for each dollar is 10 dimes, or we have, for each dollar is 4 quarters, and so on. So after defining these kind of constant numbers, we can write our total values in more meaningful ways, right? We have the pennies, we divide by pennies per dollar, and so on. We can compute the total number of dollars. So it increased the readability, and it also decreased the possibility of making some errors, right? Yes, question.
What is that?
Oh, magic number. All right. So it means,
You don't
If-
know what that number means.
yeah, it means, yeah, for you, you may know what is 3.14, right? It's, yeah, it's easy to know for you, but for others, they may ask, what is 3.14? They might think, oh, this number is magic. It's magic by you. You created it, right? But if you say it's pi, oh, I know it's pi, right? So that's the difference between magic number and a name. No more questions? So constant. This is a keyword, so you cannot define some variable named constant, and it can avoid the variables being modified, right? It's a read-only copy. And actually, in later times, maybe in C++ 11 standard or so, they have introduced something called constant expression. They actually these ones are the constants. The original constant actually means read only. This one means constant, but you don't need to know the difference. For all of you, just use constant. All right. So I just introduced some of the new things, and C in the older days they also have some ways to define constants. They don't use the constant. They use something called a define. They are called macros. You will still see some old projects, they still using this one. So as you can see, you can define penny per dollar as 100.0. As you can see, compared to constant, it has no type in here, right? It didn't say pennies per dollar is a double type. It didn't say that. It's because when compilers see this, it will simply replace everywhere this the name appears with 100.0. So for compilers, it's just a substitution. It's a replacement, right? So you don't need to define it because it's not a variable. It's called a macro for the compiler. It will replace everywhere it appears with this. So in the old days, people even write, they can define some of the functions in here. They define, instead of say the variables, they define very complex functions, and the compilers will help you to replace everywhere the name appears with a number or anything after that. It's called a define macro. But don't use it, right? It's still old styles. If you read it from other people's projects, you will be able to understand it, but it's not a good style for now. Any questions? We have I believe it's the last type, right? Yeah, it's the last type. It's called the enum, or we say enumeration. There are only a few possibilities for this type. For example, if we define what is a weekday, right? It means Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? It only has these 7 possibilities. So it's called enum. You can define enum, the name for the enum. So from now on, weekday is a type. It's exactly the same as integer, double, float. So you can define a new variable called lecture day, right? It belongs to the type weekday, right? And you can assign values from this enumeration to this variable. Is it clear what is enumeration? As you can see, Monday is not a string, right? It's not a string. It doesn't have a double quote here. It's not a string. It's just a name. And internally, when the compiler represents them, they are just the numbers. Yeah, they are just integers, starting from 0. 0, 1, 2, 3, 4, 5, 6. And you can change the value. You can say Tuesday equal to 2, and start with 2, 3, 4, 5, 6, 7. So yeah, they are just integers. They are stored inside of that. So so everything is not a string. They are just names of the values. And weekday is a type, right? You can define many new types. So this is the first one you can define. In the future, you can define class. Class is another type. So it's a type. You can use it to define variables as usual. How about the output, right? What's the output of this lecture? One, yes. Good. As we said, everything is integer, 0, 1. So this one is 1. It will output 1. It will not output Tuesday. So you're expecting it to output Tuesday? No, it's not a string. It's just an integer. It's not using double quote for it. So if you want to output the Tuesday, you need some kind of the branches that will be introduced. Maybe if we have time, I want to cover that, but I don't know. Yeah. So for if we compare it with defining a bunch of constants, right? You can also define it in this way. It's exactly the same. I want to define a constant integer. Monday means 0, Tuesday means 1, Wednesday means 2, right? It's a bunch of constants. They are exactly the same as the enum type. And you can say integer lecture day equals to some integer, right? But be careful. If you define it, allow it to be any integer, you can assign any value to it. It may be outside of the Monday to Sunday. So from the meaning point of view, enum has a better meaning, right? You constrain everything to choose from these things. If you allow lecture day to be an integer, it can be any number, right? Or even negative number. It doesn't mean anything. So enum can be used in this way. But I believe enum are less frequently used than other simple types. Any questions on this? No? All right. Yeah. I have opened it for a long time. I want to cover a little bit about control flows. Because functions, I need to maybe a lot of time to cover functions. So control flows, we don't need to recap. So what's the syntax error of this? We can think of it as a summary of what we have learned. Yeah, and? Yeah, L string, you need the bracket. Yeah, in main, the semicolon, in main, there should be a brace, right? A brace is here, so you don't need this semicolon. C out, yeah, std, namespace std, before C and C out, right? Double quote, yeah, it's double quote issues, right? And this double quote issue, yeah, this double quote, everything is less than into your double quote. So it will output the sum of less than, x, less than, right? You should code it in here, right? And this return, you need to return something, right? Pardon? Yeah, yeah, it could be true. Anytime. Yeah, because it depends on the compilers. And like I did in last lecture when I tried to define it as void and return nothing, the compiler complains. But in the older days, they don't complain. So it's because of the newer version of GCC, they have improved a little bit about that, right? All right, so what's the logic error? It's a long one. So we say first input a number, x1, right? We see an x1, and then we see out the total, right? Then we say total equals to x equals total plus x1. Yeah, should be reversed, right? Or at least if we output this one, it's outputted from initial values, but we don't have some initial values. Yeah. It's some random numbers. So when we go here, it's a computed total plus x1, then see x2, then we give it to x2. What's the next problem? Yeah, we are trying to compute the average, right? Yeah, maybe the only problem is initialize the total equal to 0. Let's see if there's any more questions. I don't remember. Total equals. Yeah, I believe that's it. Right. So control flows. We have already seen control flows actually, the ternary conditional ternary operators. Right. We are trying to implement a decisions. So based on a condition, if it's true or false, we want to do different work. So it's called a branch. Right? A branch has a condition. It's evaluated to be true or false. And for the true part, we have a bunch of statements. And then for the false part, we also have a bunch of statements. And we are trying to understand the statement blocks. And also we want to learn how to compare the strings, floating point numbers and integers, how they can be used in our work. So for this one, right? If some condition is true, we will do the statement. So here is if x is greater than 0, we will assign square root of x to y. So that's a good style, right? Always checking if this one is greater than 0, right? Remember the first time when I tried, it gave me a NaN. It means not a number. So this one, and let's see. Yeah. So typically we need some kind of the error messages. Right? We can output some error messages. For example, we want to compute the edge, the length of the edge. If we given the area of a square, right? We can say if area is less than 0, okay, it's an error. We can output to C error. So slightly different between C error and the C output. So in most cases, C out and C error will output to our the same terminal, right? But it really depends on the IDEs, and you can also control where do you want to output. You can redirect C error to output some file, or C error to output to some places. That really depends. So in most cases, you will say error messages to output to C error, and the normal informations output to C out. Right, we can revisit some of the things we have already covered. Greater than or equal to, less than or equal to, not equal, right? So first one, don't confuse comparison with assignment. So this one is assignment. And remember, this one will not have any errors by the compilers. Compiler thinks it's correct, right? When you have x equal to 3, y equal to 4, the first one is the one you want to compare, whether 3 equal to 4. This one will first assign y's value to x, then return x, right? Then we say if it is the same as if y, and at the same time you are modifying the data of x. So this is assignment, this is a comparison, and compiler thinks this is correct, right? Always remember this. Compiler thinks this will be correct. And when I was the TA many years ago, many people have these errors. When they want to compare, they do assignment, and they have changed a lot of values. Then when they check out the output, they will see, oh, what's this weird behavior? Most of the weird behavior comes from here. So the condition in an if statement can be any type, right? These conditions can be any type. We said any type can be converted to Boolean, right? True or false. So for integers, 0 means false, all the others are true. For characters, the terminate character, backslash is 0, not 0. Backslash 0 is a false, all the others are true. And for pointers, now pointers are true, are false, all the others are true. For the others, you can score omit it for now. At least for integers, you should remember. 0 means false, others means true. All right, so we will have another problem is the round-off errors, right? If we assign square root of 2 to r, if we say if r times r equals to 2 means the square root of 2 squared is 2. Otherwise, we say square root of 2 squared is not 2. Right? What's the output? Did you try it in your machine? The output will be this. It's not true. But true. But 2. Not 2, but 2. This will be your output. But actually the output is 2, right? R times R, when you want to try to print it, it will print it 2. Yeah, but the actual value is not 2, actually, right? It's 1.9 something. So that's the round-off errors we said. When you are comparing these floating point numbers, don't use the exact comparison. Pardon? Yeah. Yes. 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 So if you set the precision of Cout, this one will no longer be 2, but it will still jump to this branch, right? Jump to this statement. So what we want to cover is this is that branch, right? This is the control flow. First, we compare R times R equals to 2. The answer is no, right? So we jump to else. So we jump to else. Then we output square root of 2. Square is not 2, but output these values. So these values can be different, depends on the precisions of Cout. But anyway, you will always jump into here, all right? Jump into the else part because of the floating point number errors. You can set precision, right? V20, and to see what's the value of it. You guys can check it out by yourself. What's the output of it? Maybe I can show it here. So let's first see the initial one. Wait, so many errors. Using all right. So this is the first output we will get, right? Assign square root to R. If R times R equals to 2, it's false. So we jump to else. Then Cout square root of 2 is not 2, but R times R, right? We can set the precision. I don't remember, do we need to include some libraries or not? Let me see. No. We need to include some libraries. I don't, what? IO. Is it, let me find out. Set precision. Right. We will end here later. So you can search for it and it will tell you IO manipulate. Okay. IO manipulate. Compile and run it, right? It's actually a little bit larger than 2. Like when we set enough precision, and this cout will give us this result. So initially, because this precision for cout is not enough, so it will truncate here. So the output will be this one. But now we set enough precision, it will give you the exact numbers. Right, so that's the flow control. Yeah, I believe we don't need to cover everything today. So any questions? Any questions so far? Yes? R times R? Okay, why R times R is not equal to 2? Because R times R equals 2.0000441. It's because this one is a double. It has limited precision, right? It has 64 bits to store the result. So there are some roundoff errors. You are ignoring the remaining bits after square root of 2, right? It's, you can think of it as containing a few bits, 1.4 maybe, right? Then when you can multiply R by R, when you multiply R by R, the result will not be 2.